Don't forget us, don't forget me, everything about me.
Hi there, I'm Amy and this is Serena. Welcome back to What the Freud in our second part of this series. In this video, we'll be covering the topic of cognition and memory. Today, we've decided to zoom in on Alzheimer's disease.
So what is Alzheimer's disease? What are its causes and effects? And are there any cures out there? What is the future of Alzheimer's? We're going to answer these questions for you today.
Alzheimer's disease is a neurodegenerative disorder that slowly deteriorates thinking, communication, attention, judgment, perception, and memory. A brain that has Alzheimer's will undergo atrophy.
The causes of Alzheimer's are thought to be mainly genetics, but also a head injury, depression, hypertension, and high blood pressure. Psychiatrist Alois Alzheimer first identified and documented a patient with the disease in 1901.
Alzheimer's falls under the umbrella term dementia, which is not a specific disease. Dementia is defined as a group of symptoms associated with a decline in memory or other thinking skills severe enough to reduce a person's ability to perform everyday activities. On this note, dementia is also often referred to as a term for senility, but we'd like to explain that dementia, or serious mental illness, is not a normal part of aging.
So roughly 60 to 70% of dementia is caused by Alzheimer's, and it usually appears during the mid-60s of a person's life. It affects mainly older people and can lead to issues with performing easy tasks. From our research, the rate of Alzheimer's disease deaths was higher among older individuals. So for Alzheimer's disease, as the underlying cause, the Crude rate rose steadily from 1 per 100,000 at ages 45 to 64 to 680 per 100,000 to age 85 or older. So as a contributing cause, the rate increased from 0.4 per 100,000 at ages 45 to 64 to 433.4 per 100,000 at age 85 or older.
Additionally, the average age of death from Alzheimer's disease, whether it was the underlying or contributing cause, was about 84 for men and approximately 86 to 87 for women. The percentage of deaths that were Alzheimer's disease related rose from 1.4% among people who died at ages 65 to 74 to 4.9% for at ages 75 to 84, and to 8.2% at age 85 or older.
Alzheimer's affects roughly 35.5 million people around the world, and according to StatsCan, Alzheimer's affects more women than men. Here are some signs and symptoms of the disease.
Before Alzheimer's disease develops in the brain, there are visible symptoms of the effects of aging on memory, such as forgetting things occasionally, misplacing things sometimes, minor short-term memory loss, and not remembering exact details.
As AD sets in, the early stage begins. Here, episodes of forgetfulness becomes more frequent. Names of family and friends are often forgotten, and there is evidence of confusion in unfamiliar situations. I think these changes may only be noticed by close friends or relatives.
Middle stage AD includes greater difficulty remembering recently learned information, deepening confusion in many circumstances, problems with sleep, and trouble determining their own location. Middle stage AD includes greater difficulty remembering recently learned information, deepening confusion in many circumstances, problems with sleep, and trouble determining their own location.
Finally, late stage AD is defined by the poor ability to think or process information, problems with speech, repetition of conversations, and overall becoming more abusive, anxious, or paranoid.
There are issues with executive functioning, planning, flexibility, and abstract thinking, as well as problems with semantic learning. So this would be memory of meanings and concept relationships.
Apathy is a common trait found in individuals that are diagnosed with AD, and they tend to experience depressive symptoms, irritability, and have reduced awareness. Additionally, episodic memories, so older memories, semantic memories, which are facts that are learned, and implicit memories, so body function memories, are impacted. Long-term memories will later become impaired as well.
Muscle mass and mobility will deteriorate as the individual slowly becomes less able to move on their own. The cause of death is typically not Alzheimer's disease, but due to external factors and or other illnesses that are amplified due to it. This is why Alzheimer's disease is often classified as an underlying or contributing cause. For example, a strong infection may be caused by pressure ulcers or pneumonia, which is really in relation to Alzheimer's disease.
So because the true origins of Alzheimer's are still unknown, we don't know who it's going to affect and when. This is something that can touch all of our lives, either directly or indirectly. as psychology students, we want to discuss this topic because we want to raise awareness about the severity of this issue.
So we also want to look at Alzheimer's disease through a biopsychosocial approach. As psychology students, we want to examine all different aspects of Alzheimer's disease. Scientists may have found a mechanism linked to toxins that may lead to Alzheimer's disease. This could potentially prevent the mechanism from progressing further early on. Beta amyloid is a toxic protein or peptide that builds up in the brains of people with Alzheimer's and triggers a mechanism that disrupts the functioning of dendritic spines. These are tiny structures in the branching parts of brain cells that receive signals from other brain cells. The mechanism disables covalent 1, which allows the dendritic spines to function properly. Exposure to the peptides can cause covalent 1 to take on its inactive form. The beta amyloid peptides can lead to fewer dendritic spines that can be lost. Brain cells have a cytoskeleton that keeps the shape of the cell and helps the dynamic transport inside the cell keep working. They have this ability because they consist of active actin filaments. Covalent 1 breaks into smaller units, which keeps the dynamic working. Beta amyloid peptides in brain cells can lead to phosphorylated covalent 1, which makes the protein inactive. This negatively impacts the effectiveness of the dynamic and harms the dendritic spine's ability to receive signals. Research has shown that an enzyme, Rho-associated protein kinase, ROC, could be a target for reducing the phosphorylation as it can activate and deactivate certain molecules through the process. The drug Fascidil can block ROC and stop the dendritic spines and synapse damage caused by the beta amyloid peptides. More research is being done in regards to stopping phosphorylation during the early stages of Alzheimer's. So in terms of biochemistry, a protein misfolding disease caused by accumulation of plaque of abnormal folding of beta amyloid and tau protein in the brain can also be a factor in Alzheimer's disease. Beta amyloid is a fragment of the amyloid precursor protein, APP, which is a transmembrane protein that is important for neuron growth, survival, and repair. What happens during Alzheimer's is that gamma secretase and beta secretase act together in a proteolytic process that divides APP into smaller fragments. One of these fragments will lead to fibrils of beta amyloid, which will form clumps that deposit outside neurons. These clumps are cyanide plaques. These fibrils are toxic and can lead to programmed cell death. It can also inhibit certain enzyme functions and the utilization of glucose by neurons.
So there's a few other hypotheses that are also being considered Alzheimer's. One of them is the cholinergic hypothesis. It proposes that AD is caused by the reduced synthesis of the neurotransmitter acetylcholine. However, it's not widely accepted due to drugs that treat acetylcholine deficiency have not helped. So there's really not too much on that. There's also the tau protein abnormalities hypothesis. So the disease is initiated by hyperphosphorylated tau pairs with other threads forming a forming neurofibrillary tangles inside nerve cells. This causes microtubules to disintegrate and damaging the cell's cytoskeleton structure, impacting the neuron's transport system. This would lead to problems arising in the biochemical communication between neurons and would lead to cell death. And there's also the genetics theory. Yeah, so scientists have found that genetic heritability ranges from 49 to 79% based on family and twin studies. So based on this, it seems highly probable that if somebody in your immediate family has Alzheimer's, there's likely a good chance somebody else, like you or somebody else, can have it. So autosomal dominant AD can be linked to 3 possible mutations: amyloid precursor protein, presenilin 1, and presenilin 2. These mutations usually result in the increase of beta amyloid 42 specifically, which is the main component in senile plaque and can be considered as neurotoxic. They can also alter the ratio of these proteins. Variants of genes ABCA7 and SORL1 are associated with the disease as well. Possession of the E4 allele of the apolipoprotein E gene can increase the risk of having the disease by 3 times if it's heterozygous and by 15 times if it's homozygous. So these have been there have been a lot of studies in regards to the genetics of Alzheimer's. However, results still haven't been completely conclusive, so they're still not 100% sure about the link here. So there are various types of diagnosis you can do for AD. Usually diagnosis is based on medical history from relatives, and behavioral observations. CT, MRI, SPECT, and PET scans are used to help differentiate the different subtypes of dementia as well as the different stages of the disease. Assessments of intellectual functioning can be performed to determine state and level cognitive impairment. So the National Institute of Neurological and Communicative Disorders and Stroke and the Alzheimer's Disease and Related Disorders Association established the most commonly used Alzheimer's criteria for diagnosis in 1984. And it's been recently updated in 2007. These criteria require the presence of cognitive impairment and a suspected dementia syndrome, be confirmed by neuropsychological testing for a clinical diagnosis of possible AD, and a histopathological confirmation, including microscopic examination of brain tissue, is required for a definitive diagnosis. 8 intellectual domains are most commonly impaired in AD, so it's memory, language, perceptual skills, attention, motor skills, orientation, problem solving, and executive functional abilities. Supplemental testing provides extra information on some features of the disease, or is used to rule out other diagnoses. So blood tests can identify other causes for dementia other than AD, causes which may be reversible, however quite rare. It's common to perform thyroid function tests, assess B12 to help rule syphilis, rule out metabolic problems, including tests for kidney function, electrolyte levels, and for diabetes. Assess levels of heavy metals such as lead and mercury in the body, and anemia. It's also important to rule out delirium. Testing for depression is also conducted, as it is possible that it is concurrent with an early sign of or a cause of Alzheimer's, which is interesting to consider when looking at the connections between mental health and the biology and body of an individual. So recently, stress has been placed on diagnosing Alzheimer's before it even begins to show up in someone's life. Some tests involve the analysis of cerebrospinal fluid for beta amyloid, total tau protein, and phosphorylated tau, 181p protein concentrations. So, as we mentioned, like tons of scientists are trying to find different ways to prevent it before it even happens, and finding the underlying cause for AD.
Let's talk prevention. So there's no actual evidence to support these prevention methods, as these are mainly linked through correlation and proposed relationships. So just a disclaimer. Various medications have been thought to help prevent or deal with the disease, however they all have inconclusive results. Participating in intellectual activities such as reading, playing board games and card games, playing an instrument, maybe learning other languages or social interaction, and having going back to formal education, they can all be used to prevent the disease, but there's no proof that these work. This is looked at using the cognitive reserve theory, which suggests that someone can have a reserve that delays the onset of dementia due to life experiences that result in more efficient neural functioning. This is where things such as apps and games come in, where they're like, exercise your brain, so you get your brain working more every day, and so you're learning something every day, or you're doing something new with your brain, so you're kind of constantly keeping your brain active. Physical activity is also supposed to help delay the symptoms of dementia and is used to reduce the severity of the disease. And if we talk about diet, this is mainly correlational. So a Mediterranean or Japanese diet can reduce the risk of developing Alzheimer's. So this is something that we found through our research, because there's a lot of consumption of seafood, which is high in important substances like omega-3. This is typically associated with promoting brain function. However, omega-3 supplements have little to no effect on individuals with Alzheimer's, so this kind of proves that the theory is inconclusive. We found that a diet that is high in saturated fats and simple carbohydrates have higher risks, and this is commonly found throughout North America and Europe. So something else that may help is the moderate intake of alcohol, so a lot of red wine, or some caffeine in the form of coffee and tea, as well as cocoa. Vitamins and herbs may reduce factors, but there's not enough data out there to support this. There are currently 5 different medications used to help the disease, however their effects are minimal. Serena will explain more about some medication.
So new medication is being developed every year, however only a few actually get approved. So vaccines and therapy are currently being developed to reduce beta amyloid, and this is to train the immune system to locate and attack the peptide early on. 2 clinical trials have worked of the drug to inhibit tau aggression as well. This has been the last few years, so hopefully, science will be able to pick up speed with that. So behavior, we're going to try to promote more mindfulness and meditation.
And so this goes along with lifestyle. So if you change your diet and you change your behaviors and your practices, this may influence the development of Alzheimer's disease within your own brain.
There has been also more research conducted towards infection and its relationship to Alzheimer's. So herpes simplex virus, HSV1, has been found in the same area as amyloid plaques, which has led researchers to believe that the plaques can be treated with antiviral medication, and they also have found promising results. Our recent finding has provided an insight into fungal infection theory and correlates with the amyloid-beta hypothesis and other fungal infection cases.
So overall, we'd like to conclude and say that although the cause of Alzheimer's is not exactly known, there are a lot of factors, including genetics as well as biochemistry. And as students, we like to pursue this field of study because it relates to our lives and it can affect anyone, maybe around us or you as an individual. And we hope you enjoyed our biopsychosocial approach to Alzheimer's. Thank you.
Don't forget us, don't forget me, everything about me.